Okay, so the first thing we're going to go over is this problem here. Anytime you see an acid or a base with a halogen times 2, such as this, you have alpha-halogenation. And in alpha-halogenation, all you're doing is replacing one of the alpha hydrogens with whatever halogen that's in the reagent. So in this case, we have Br2. So to get straight to your answer, you just replace one of those alpha hydrogens with a Br. Okay, so the next question here, they give us our product and we want to know what the reactant is as well as the reagents. So it looks like it's some sort of an acetoacetic, and I know this because I have a carbonyl group here. And in acetoacetic, it's really easy to get rid of the ester part on the right side through hydrolysis and decarboxylation. So an acetoacetic looks something like this. And for the purpose of this question, I'll make my R an ethyl group, just to make things a little easier. Okay, and so what I want to know is how do I add this R group as well as this R group right here? And keep in mind, this is the alpha position. So I know that 2 alpha hydrogens got replaced by these 2 R groups. So let's start with the yellow one first. So in order to do that, I'm going to need some type of base to deprotonate my alpha hydrogen position, as well as a halogen, so I'm just going to use Br for this case, and the R group. And this R group right here is the yellow that you see. It's the 2 carbons. And so for this, what you do is you deprotonate the alpha hydrogen through the mechanism of the OET, removing the alpha hydrogen, and you do an SN2 reaction, which basically attacks this position right here, and this bromine leaves as a leaving group. So you get something that looks like this. But you still have another alpha hydrogen. So I know that I have this yellow part already added, and because I have another alpha hydrogen, I can do another step in which I can add another base like this, as well as a halogen, which acts as my leaving group, plus the R group that I'm going to add. And with that, you get something that looks like this. One, two, three, four. 1, 2, 3, 4. Making sure that I have all my carbons and I didn't lose any. And after that, you're going to do hydrolysis, which is basically an acid with water, and also decarboxylation, which is heat, and that removes a CO2. And with that, I get my product. And this whole group, basically with hydrolysis, it converts this ester to a carboxylic acid derivative. A carboxylic acid, because a ester is a carboxylic acid. And anytime you add water to a carboxylic acid derivative, you get your carboxylic acid back. And then when you do decarboxylation, you lose that carboxylic acid. Okay, so for the next one, it looks like just some type of carboxylic acid with a carb acid derivative. And we talked about this in session, what these carboxylic acid derivatives are. So there's, you have your acyl chloride, you have your acid anhydride, you have your ester, and you have an amide. So this is an amide. And in order to get to your amide, you need to add this reagent. So since I have NMe2, I know that I have HNMe2 because you lose the hydrogen through the mechanism and you're just left with this group right here. that replaces your OH. Okay, so for this next one, we're using LDA plus an R group and a leaving group. And then we have another equivalent of that here too. So for LDA, I drew it right here. It's a strong base, and it's used to attack at alpha carbon that is least substituted. So here we see we have two sides of alpha carbons. We have one here and one here. And so we see that at this position 1, I'm just going to call it alpha 1, and this is alpha 2. We see that at alpha 1, it's most substituted because we have an addition of this methyl group that's right here. Whereas in the second alpha position, we don't see that. So for this first one, we're going to add the ethyl group on the right side where it's least substituted. And all LDA does is it's a base that removes the hydrogen here, and it does an SN2 reaction. The leaving group, which is iodine, leaves, and you have the added ethyl group. So next we're going to do another equivalent of LDA with MEI. And so we still have 2 alpha positions, but we see that this right side right here is now more substituted. So we're going to add the methyl group on this left side. And so we get something that looks like this. Sorry, this is a methyl, not an ethyl. And so we get something like this. And that's your final answer. And if you haven't, please sign in the description box.